So today we're going to be looking at that last type of surface water that we have yet to examine, and that is glaciers. Glaciers are water that's found on top of the land. It's not groundwater, so this is surface water. First of all, the very particular wording of a glacier, and it's very important that you pay attention to the wording of this. I've got it as simply stated as I can, where we still get the main idea of what a glacier is. A glacier is a slow moving mass of ice on land. So some important points here. It's got to be ice, it has to be moving, and it is found only on land. An iceberg is not a glacier because it is found floating in the ocean. Some examples of glaciers. First of all, there are two types. There are valley mountain glaciers, also called alpine, referring to the mountains, and there are ice sheets. This is an example of what a valley or mountain alpine glacier looks like. Glaciers have been described as being a slow moving river of ice, and you can almost get that sense here where it seems like the ice is flowing downhill, because in actuality it is. It's not flowing water like a river or a stream like we typically think of. It's frozen water that is being pulled downhill by gravity. Here's the Franz Josef Glacier in New Zealand. You can get the sense here. That glacier is moving down the hill. This is a better example of what's called an ice sheet glacier. And these are a little bit harder for you to get a visualization of, because it's basically just one big, huge, massive sheet of ice that covers everything. So they're very much larger, they're wider, they're broader. Hard to get a sense of what they actually look like. Now, how big can the ice be in a glacier? Well, they can be really thick. In places like Greenland or Antarctica, they can be up to a mile thick. I like this picture because it's got a cruise ship, which if you've ever been on one, you know how big these things are. They're really, really large. They're massive, and it is smaller than the glacier it is parked beside. Here's some people walking up the face of a glacier to give you some sense of scale about how big and how thick the ice can be. Same thing here. You see the people over there off to the right, and here's where the glacier is flowing down the hill. You see these people are really, really small compared to the thickness of the ice. And this is actually a smaller, thinner part of the glacier. So where are glaciers found? Well, they are found in all continents except for Australia. Australia is just too warm and too dry to have had glaciers. You'll notice from this map, though, there are some glaciers that are found very close to the equator, some in South America and some in Africa. And you should ask the question, how can glaciers be found near the equator where it's always so hot? They're ice. Doesn't the ice melt? Well, the trick is with glaciers near the equator. If you are high enough up on the mountains, you know it's going to be cold enough at that high enough elevation to have glaciers. So glaciers near the equator have got to be on mountaintops. But you'll notice that it seems like more of our glaciers are up here a little bit further from the equator, either direction, where it's going to be colder. In the United States, where do we have glaciers? These are the continental states that have glaciers, and you don't necessarily need to write down the names of all of these. What you do need to understand is that in the United States, glaciers are found in the west. We don't have any glaciers back here in the east. The reason that we have glaciers in the west, even though it rains and snows less, is because we have higher mountains there, where it can stay cold enough year-round so the ice doesn't melt. Back east, it might get cold enough, and it certainly rains and snows enough, but the mountains are so much lower that even in the summertime, the temperatures get warm enough for the ice to melt. So no glaciers in the east, they're only found in the west. However, Alaska is glacier central. It has more glaciers than all the other states combined, and it has approximately 600 glaciers that are so big and so noteworthy that they were actually given names. This is what it looks like flying over Alaska from the air. That's a glacier. You can see it's a river of ice. You can see that's another river of ice, and they come together at this confluence here. Here we've got another river of ice. So the whole state of Alaska is nothing but these rivers of ice that cover up our mountains up there. And it can do so in Alaska because it's far enough north stays cold enough, and these are high enough mountains. It's a big popular tourist attraction to go see the glaciers in Alaska. Okay, this is Glacier Bay National Park, where I showed you the picture of the cruise ship and get right up next to the glaciers. You can take an airplane, you can fly and land on the glaciers, and you can do your hiking and skiing and such. Some places you can get out of your car and you can walk right up to the glacier. This is called the tongue of the glacier. This is the end of it, where it started off up here in these mountains and it is flowing downhill, and you can walk right up to it and get on the ice. This is Seward, Alaska's exit glacier. You can see it snows a lot up here. The snow builds up and then it pushes itself to flow downhill. This is Mendenhall Glacier in Juneau. You can still see the same thing. You can get the idea how it snows a lot up here, and then it kind of slowly slides down here. Now this is summertime, so the end of the glacier is melting a little bit more, and we get a little lake down at the bottom. Other significant glacier locations, Greenland, and you can see here this is a good example of an ice sheet because it just covers everything in one big huge thick chunk of ice. Iceland is very famous for its glaciers. You can see them flowing out of the mountain here. There's one. There's another one coming down over that way. Once again, Iceland far enough north, gets a significant amount of precipitation. They have lots of glaciers. There's the name of one of the glaciers. This root word here is glacier in Icelandic. So this is the Fla Glacier. You can walk right up to it and you can touch thousands of year old ice. And this is what a glacier looks like up close. It's not snow, it is solid ice. You want to, you can take a lick or a drink, and you can be drinking 10,000-year-old water that's been stored in that glacier. Antarctica, another place with lots of glaciers. So how fast do glaciers move? In one word, slow. We're talking centimeters per day. You can't sit there and watch a glacier move in one day. You wouldn't notice it. Now, glacier formation. How do glaciers form? First of all, number one, up here, we get snow falling. That's the first step. You got to be someplace where you're high enough in elevation that you get snow instead of rain. You got to get enough of it. The snow's got to fall. That's step one. Step two, the snow has to build up. The snow piles up. So not only do you have to get snow, you have to get an incredible amount of snow just piling up here on top of the mountains. That's step two. The snow piles up. It squeezes together and forms really, really compact solid ice. Three is gravity. Gravity pulls the ice downhill. That's the movement part. You can have all the snow you want on the top of the mountains, but if it's not being pulled downhill by gravity, it is not a glacier. So one, it snows. Two, the snow piles up and squeezes together to make ice. Three, gravity pulls the ice downhill. Number four is where the glacier melts or breaks at the bottom, where it ends up losing some of its ice. So those are the steps in glacier formation. Now there's two distinct areas with glaciers. There's this zone of accumulation, the area up here where it is snowing and the glacier is gaining ice. That's where the glacier is growing. But as it pushes downhill, it gets to some point where it's warm enough that the glacier then starts to melt. That is called the zone of ablation. Glacier starts to melt, or it starts to lose ice by the process of calving. Calving is just when chunks of the ice break off into the ocean. That's making of icebergs. This is what calving can look like. The water's going to be warmer than the ice, and when the ice hits the water, it just snaps and breaks and pops and then floats away. That's how icebergs are formed. Now, a glacial advance and retreat. Advancing glaciers are one that are getting more snow faster than they're losing it, so the glacier's getting bigger. A retreating glacier is one that's losing ice faster than it's gaining. That means the glacier is overall getting smaller. Now, keep in mind, every year, the glacier is going to advance some in the winter, because it snows more, and it's going to retreat more in the summer when it's warmer. Now that's not what we're talking about, advance and retreat. We're talking about at the end of the year, after the end of all the seasons, at this point, is the glacier bigger or smaller than it was last year? Did it gain more ice this year, or did it lose more ice? At the end of the year, was it bigger or smaller? You can take a look at some of our glaciers. Here's the Muir and Riggs glaciers, and you can see a big difference in the size. In 1941, the glacier was all the way down here. It was way past this picture. Now it is way up there. This is an example of a retreating glacier. This is one that at the end of every year, it's smaller than it was the year before. This is one of the big arguments or big piece of evidence that's used to support the idea of global climate change, is that every year these glaciers are getting smaller, so at the end of the year they've melted more, planet must be warmer. But not all glaciers are retreating. There are some glaciers that are actually growing, such as the Hubbard Glacier here in Alaska, and scientists are really trying to figure out, well, why are some retreating and some advancing? More are retreating than advancing. Let's talk about Ice Age. And no, we're not talking about this movie. An ice age is a period of time when the Earth's temperature was lower, so we had more glaciers. Because at the end of the year, the glaciers had gained more ice than they had melted off in the summertime. So how many ice ages have we had? We've had about 5 different ones in history, with the last one ended about 10,000 years ago. Now, why these happen, we don't know, and scientists are still trying to figure that out. There is a prediction that we'll have another ice age in about 23,000 years, and it's all part of that continuing change in the global climate from hot to warm to cold to back again. Here's the extent of the last ice age, the one 10,000 years ago. You can see it was mostly up in the upper Midwest and the Northeast. This led to the formation of what we call kettle lakes. So when the North was covered with these big, huge ice sheets, and the ice sheets started to retreat, they started to melt. Big chunks would drop off and sit there. Now, it wasn't in the ocean, so it didn't float away. The ice just sat there. Well, the ice is heavy, so it sunk into the ground, made a little hole in the ground. Well, the ice melted, and what we were left with was a hole in the ground full of water. We ended up with a lake. Now, these were called kettle lakes because they were formed 10,000 years ago from melting ice. There's no river that flowed into here. These were specifically formed by glaciers. You can see them up in Minnesota. Minnesota is known as the land of 10,000 lakes, and the reason they have so many lakes is because that 10,000 years ago, that last ice age dropped lots of chunks of ice in place as the ice age ended. You'll see it a lot in Canada as well. Lakes all over the place. And these were all formed from a big chunk of ice was dropped right there, right there. As the glacier was going back north, it was dropping these chunks of ice, and they melted in place, made these little lakes. So where would we expect to see kettle lakes? Pretty much in the Midwest and the Northeast. Very much so in the Midwest. They're very much more common in the Midwest. Here's the kettle lakes that we have here in Georgia. Notice there aren't any. The reason being is the ice age never got as far south as Georgia, so we don't have kettle lakes here. You have to go to Minnesota, Wisconsin, the Midwest. So what effect do these ice ages have on the world's water? How does it all tie together? Well, the amount of water that's in glaciers affects how much other water is in the ocean. So if more water is frozen in the glaciers, there's less water in the oceans, and sea levels will go down. So during the last ice age, there was a lot more water that was frozen, which means it wasn't in the ocean. The ocean levels went down. And this map here shows you what the coastline of Florida used to look like. We know that this area here off the coast of Florida used to be dry land. Now it's not now because the glaciers have melted after the last ice age and ocean levels rose. The way we know that this area here was dry land is because you go out there and you have found fossils of land, animals, plants, trees, things that don't grow in the ocean. So that tells us that that area there must have been dry land at some point. And the only way for that area to have been dry would be if the water was somewhere else and that water was locked in glaciers. Now, if the glaciers continue to melt like they have had in the past, the ocean levels will rise. And we know the ocean levels have been like this in the past. We know that that we've gone through warm periods where there have been a lot less glaciers. We know this because if you go to South Georgia, Middle Georgia, and you start digging around in the soil, you can find fossils of shark's teeth. Well, that means Georgia at one time was underwater. The only way Georgia could have been underwater would have been if more of the glaciers had melted and more of that water went into the oceans, ocean levels rose. So the amount of water in the glaciers greatly affects sea levels. There is a thought that ocean levels are going to continue to rise because we're in that warming period and the glaciers are melting. This would be an increase of sea levels of 170 meters, and you see a good portion in the southeastern United States underwater, all the Amazon basin, fair amounts of Eastern Europe, parts of Australia. And this is the big concern right now, is the places that are lying low as more glaciers melt, the ocean levels are going to rise, and that's going to displace people. It's going to take away where they live. If you think about, look at Florida. All of Florida is entirely underwater. Think about if all those people in Florida had to go live somewhere else.